Pictured here are exponential decay graphs. This is what the graph looks like when our b value is less than 1. Actually, that should have between 0 and 1. That means that my value is decreasing over time. I still have a domain of all real numbers. My range is greater than 0 because I don't ever touch the x-axis. All that I'll ask you to do is identify decay graphs from the start value. So start value here is 2, start value of 2, start value here is 3, start value of 3. It's also really important that you can look at a rule and determine if it's decay or growth, and look at a graph and determine if it's decay or growth. So the only graph here representing growth is this one. Growth is getting bigger and bigger and bigger. This is my only rule representing growth because my b value is greater than 1. That means this graph is h of x as my only growth graph. Differentiating decay, I won't ask you to differentiate based on the slope. I'm just asking you to identify the start value. So this one has a start value of 3, must be f of x. Start value of 5 must be g of x. If asked to sketch a decay function, make sure that it's not going beneath the x-axis. Make sure that it has arrows. So it should look something like that with the start value labeled. Similarly, if asked to sketch growth, it does not look like that. There's an asymptote on the y-axis, arrows going forever to negative infinity and positive infinity, does not touch the x-axis. So this is growth, start value. This is decay. Y-intercept is still the start value. Decay, getting infinitely smaller, smaller, smaller. Growth, getting infinitely bigger, bigger, bigger.